Hello, Math 112 fans. Going to talk about definite integral skills. Again, this all boils down to what we call the fundamental theorem of calculus. We talked about a little bit why that comes from. I could go back to that, but I think it'd be better for me to focus here on evaluating. It's still the same approach. So we rewrite the way we write before, 3y to the negative 2 dy. We find an antiderivative like we were doing before. So this becomes, the power goes up 1, so it becomes -1. You divide by -1. And then you evaluate at 1 and 3. So the fundamental theorem of calculus said the following. If you can find an antiderivative, the antiderivative can be interpreted as an area. And then you can use that to actually compute the area of the region by plugging in the two endpoints. So that was the concept you were playing around with in 13.2, and then you're using it again in 13.3. Okay, so when you go to plug in, there's a little bits of advice I mentioned in class. One is it's usually easier to rewrite it the way an algebra student would write it before you plug in the 3 and the 1. And this is just reminding us to plug it in this way. If you're having trouble understanding this, this is the f of x, or in this case, f of y. That's the function. This is the little f. We found an antiderivative. We need to plug in 3 and 1. This is the standard notation for writing that. And then we'll be done when we plug in. So now you have two things to do. You plug in the 3 everywhere, 3 over 3. And you plug in the 1 everywhere over 1. And then we get what pops out. So this is going to be -1 plus 3, because it's negative, equals 2. Now I grabbed my calculator here. Let's move this up. Oh, wrong one. Because you are going to do a little calculation at the end, but I think in this case you could handle it. 3 over 3. Okay, so here's another one from the homework, and then I'll do a few from the old exams. So let's scroll up a little bit. So here we're trying to find this area. It starts here at 2. Again, here's how you think about it. Where's the beginning? Where's the end? So this would be the area or the integral from -2 to 0. And then from the function down to the axis. And so that's just x cubed plus 8. So it will be that area. So you do antiderivative, 1/4 x to the 4th plus 8x. Evaluated from -2 to 0. And then, if you need to, you can always just stop and rewrite your function with a blank in there. Plus 8 blank minus 1/4 blank to the 4th plus 8 blank. Let me grab my calculator here and put it in the corner. Okay, so now we're about to do some calculation. We're going to plug in a 0 here, and a 0 here, and a -2 here, and a -2 here. Now you should see that that's 0, and you should see that this is -2 to the 4th. You should know, since it's an even power, it doesn't matter. I mean, if you had to push a button, 2 caret 4. I mean, I definitely encourage you to use your calculator in this way, where you just do little calculations. So this would be 1/4 times 16, because it's positive, minus 16, and then we have it. Oops, it's getting into my head here. Okay, so this is going to be -4 minus 16. So it's -12, so it's 12. And that was a homework question, so you did that. Okay, so now let's look at the old exam questions. This is spring 23. Now, we don't have a way to do this directly, so we have to expand. This really doesn't have to do with definite integrals. It just is an integral fact in general. We don't know how to do that. We want to, even if you had other techniques, this is what you'd want to do, is expand. So it became x to the 3rd because I had one more x. Now we integrate. So this is going to become x to the 4th, and then a 4 is going to come down, but that cancels that 4. This is going to become x squared, but a 2 is going to come down, so it's going to be 4 over 2, which is 2. And then we're off to the races. So compute. So we are going to do to the 4th. We're going to do squared. We're going to do the 4th. And you've done this. You just did this in the homework, so hopefully this isn't too bad. But 2, 2, 1, 1. Let's see what we get. So it's 16 plus 8. You can see I don't even like to reach for the calculator. I feel like it slows me down. 24 minus 3. So the answer is 21. Let's keep going. This is the winter 19 exam. So here we have an e to the x, so we're going to have to do that, but you have to expand once again. So before we can start, let's write it so we're ready to do calculus. X to the third minus 3x squared plus 4 e to the 2x dx. Now we need to do the antiderivative. Notice how it's helpful to have this notation because sometimes people forget, have I taken the derivative? Have I not? Have I done the antiderivative? The moment you're done doing antiderivative, you move the notation over to evaluation. Okay, so this is going to become an x to the fourth. You divide by 4, this is going to be 2. This is going to become an x cubed. You divide by 3, so that becomes 1. This one's going to be an e to the 2x. You divide by 2, it's going to be 2. That's one of our rules. Now we're going to plug in 0 and 1. And then we're done. The moment we're done calculating that. If you want to see me do it, 2 blah to the fourth minus this cubed plus 2 e to the 2 times blah minus 2 blank to the fourth. That's that fundamental. That's what you were doing in if you didn't quite understand it then, hopefully we understand it now. That's what you were doing in that section. Now we're plugging in a 1, 1, 1, 0, 0, 0. And this gives me 2 minus 1 plus 2e squared. And this gives me minus 0 plus e to the 0 is 1, so this is just 2. And so you get 1 plus 2e squared minus 2. So you get 2e squared minus 1. You can just leave it like that. That's fine. Last one. We expand. So let's get the integral from 1 to 2. If you multiply this x, it's going to become a 12 over x squared. If you multiply this x here, it's going to become a 3. Now, calculus students would write this like this, 12x to the negative 2 plus 3, and then they would integrate. So let's play that game and then evaluate. So this becomes x to the negative 3, 12 over negative 3 plus 3x. I made a mistake. Notice it right away. The power should go up 1. You know, that's the important check you should always do. I made the mistake that a lot of students make. If you add 1 to negative 2, what do you get? It becomes negative 1. This is a negative 1. We're evaluating from 1 to 2. I would rewrite this as 12 over x plus 3x because I know that's just easier for me at least to plug numbers into. And then let's go. So it's going to be negative 12 over something plus 3 times something. Negative 12 over something plus 3 times something. Now let's put those numbers in. So we're going to put a 2 here, a 2 here, a 1 here, a 1 here. And I think the numbers probably come out nice. If this was a test, I tend to make the numbers nice. So it's worth your while to simplify. Oh, that's 0. And this is going to be negative 12 plus 3. So it's 0 minus negative 9. It's 9. Done. Those are those skills. All right, hope that's helpful.